Good morning. So for this last part of our QC workshop, I wanted to talk to you a little bit about crossover studies. So crossover studies is one of those things that we have to do in the lab. So unfortunately, there's no QC yet that we can use for years and years and years. Remember that when you're using your quality controls, always talk to your provider, always talk to Bio-Rad, and try to get as long shelf life as possible so that we can minimize the crossover studies. But for some products, shelf life is shorter, and there's always going to be a time when we're going to have to go to a new batch. We haven't found a magic solution yet to make a QC which can last forever, or batches that are exactly the same. We're looking at it, but we're not there yet. So when we start and we do these crossover studies, what is our current process? And can we simplify these crossover studies? And I didn't make this up. I used the C24 CLSI guideline. And you will also see at the end of the presentation, I'll give you a short example of how a data management software can help you in getting through this process more quickly. So what most of the time we're doing now, so we're running our QC, we have a lot, we have a mean, we have a standard deviation, everything's running fine. And hopefully when we get to the last box, people remember like, oh, it's time to start our crossover and start thinking about the next lot. And so what happens is we take our new lot and we start running that new lot in parallel with the current lot that we have. So most people probably still use the magic number 20. So we run our QC 20 times for 20 different days at the same time as we're running our current quality control. And after those 20 days, we now have a target, we have a mean, we have a standard deviation, and then when we use our last vial of our old lot, we can actually use the new data we have with our new lot, and we can continue and use that data forward. So let's see, after our current process, what could we do to improve this or streamline this a bit better? So let's start with our standard deviation. Well, that's actually the easiest one because we actually don't really have to establish our new standard deviation. Our standard deviation is normally more an expression of our instrument performance, not really our quality control performance. So we could use the standard deviation, the current standard deviation of our current lot that's being used is actually very powerful to use, way more powerful than just doing our 20 points of a new crossover study. So we can take that standard deviation over a long period of time, and that includes a lot of variation of the instrument. We have calibration changes in there, we have calibration lot changes maybe, reagent lot changes. There's a lot of users that have used the system. There's maintenance that we've done daily, weekly, we've replaced parts of the instrument, so everything is in there. Environmental factors, temperature, humidity, all those things are all part of that variation and that imprecision of our instrument. So that actually makes it the best possible evaluation or estimation of our standard deviation. Remember that when our new target of our new lot is close to the old lot, we could actually just copy the standard deviation because the standard deviation is our absolute value. But most of the time, it makes it a little easier to use our coefficient of variation, or CV, because if our target changes, that actually helps us to move over that same imprecision. And I just put a little example in there. If we're looking at our current instrument and we're having our current lot 120, with a current standard deviation of 5, so we have a CV of 4.16. So when we would go to a new lot, our mean might be 142. If we would just copy that 5 for the standard deviation, what actually is happening is we're actually narrowing our limit because we're actually putting a tighter CV in for our system. So if we take that 142, it is better to take our CV, we copy that CV over to our new lot, 4.16, and we can calculate the new standard deviation if we want. So here it would be a 5.9. If there are products that we have that have very short shelf life, then our CV or our SD might not really be the best estimate or might be really short and limited. So for example, like if we talk about hematology or other products that have a short shelf life, we have multiple CVs and SDs from different lots. And we can actually combine those to calculate a more long-term SD or CV, and you can do that with this pooled formula. So you will see that you will use the individual standard deviations of each lot and also use the amount of data points you used for that, and you can combine that to a new pooled standard deviation. Also, when I was talking about those variations like calibrator lots or reagent lots, they were all acceptable changes. If something happens with your system and there's actually a significant change, like an example here, maybe a reagent lot or a calibrator lot change, and there is a significant shift, you have to be careful that you don't use that shift and include it in your calculation of your standard deviation, because that might artificially increase that value. So even if you have an example like this, it might be better to just use this last part of the standard deviation of the instrument. Or what you could also do is break this up into two groups with each their individual standard deviation, and then you can use the pooled formula to combine those together. So I put a little example in here. So I show you lot A and lot B, but lot A and lot B could also be 2 months of the first of your current lot and 2 other months after you had the shift of a calibration or a reagent or a maintenance, for example. So what you see is that your lot A was running at a mean of 15 with a standard deviation of 1, so a CV of 6.6, and lot B has a little different mean, so it has 17. Similar standard deviation, similar CV. But if you take those two sets together and you would calculate the standard deviation for those sets together, see what happens. You are actually getting a 1.44 standard deviation or a CV of 8.9. So if you would be using that long-term CV and there was a shift or something happened, your CV is now a little higher than you really want to. So if you would calculate a pooled SD with these two data sets, you would actually get a 1.06 or a CV of 6.5, which would be exactly what you want to use with this data set. Don't use insert ranges. Don't use analytical performance specifications. Don't use peer groups. All these targets are there to help you, but they are not there as your standard deviation target. So insert ranges are often a target from us to give you, your mean should fall within that established range. That range is not there for you to go and you take the difference between the mean and the upper limit, divide it by 2, put that in as a standard deviation, and we're off. That is not how it works. You have to establish your own standard deviation and your own variation of your instrument. Analytical performance specifications, like biological variation, like your CLIA limits, also are not what should guide your instrument. They are a target for quality, but they are not what you should use to evaluate your instruments. I've seen examples where people say, okay, I take my biological variation, I'll divide it by 2, I'll put that in as a standard deviation, and we're off, and I'm good. So often that will give you a false sense of security because you think you're running everything okay, but you're not. One of the things I like best is I like looking at the Levi-Jennings. And when you look at the Levi-Jennings, and you see, for example, that all your data points are between -1 and 1 standard deviation, guess what's going on? Your limits are way too wide. Some labs tell me, oh, we never have any problem with this test. You open the Levi-Jennings and you're like, yeah, you're never going to see a problem either. If everything is exactly on your target and your standard deviation is set so wide, people go like, oh yeah, I use a 1.2s and no false rejections at all, no problem. But you're actually using maybe a 1.6, 1.7, 1.8 SD rule if you set those ranges so wide. So be very careful with those ranges. So we have our standard deviation, that was easy. So now let's go to our mean. So how do we get our mean? Well, it's actually also pretty easy. So instead of our 20 that we always used, to establish a mean, we don't really need 20, we can get away with 10. So 10 results on 10 separate days is powerful enough to give us an estimate of our mean. I didn't talk about the SD at all. So again, this would never work to estimate your standard deviation because it's not enough data, not enough variation, but for your mean, this is enough. CLSI, the C24 also state, try to include a calibration event. So it is trying to include some of that variation that happens on our instruments. If you use your QC vial frequency, for example, if your normal use is 1 QC vial every 2 days, try to do the same for your crossover study. Most of the time, if you're just running 1 QC a day, you might get away with using 1 vial for your 10 days. But that also means that you minimize the variation because you're only using 1 vial. We all know that if you would use liquid material, then that variation of your QC is less than if you would use lyophilized material, because then you have a reconstitution, and that also adds to the variation of every individual vial. So if you use lyophilized materials, it's interesting to just make sure you have a couple of vial changes also in that crossover study. Remember that our current lot that we're using is still used to evaluate our instrument performance. So if that current lot is showing that something is out of control or we have to make a correction, make sure you reject your crossover results and you add an additional run when the out of control condition is corrected, so that we make sure we get to those 10 points and we don't have any incorrect results in there. Again, like I said before, don't just take the insert value and set that as a target. Don't take the peer group value and set that as a target. It's interesting information, and again, if you use your assayed controls, your mean that you're establishing should be within the range of the insert, but it doesn't have to be the insert. If you participate in an interlab program like Unity, you can actually use a couple of our reports, and actually one of them is called a statistical profile report. If you look in that report, you'll see that a peer group has a normal distribution. Not everybody finds exactly the same result. So if our target for our assayed control is 100, there's labs with 98, there's labs with 102, there's labs with 100, but you don't have to focus or force your instrument to report that 100. It is acceptable to be within that range, and it is more important to follow up your target in your lab than to try to skew yourself to that insert target. If something happens, like I started by saying, like, well, if we take our box out of the fridge and we say, hey, last box, I also know labs that say, hey, last file. So if that happens, then yes, unfortunately, you have to go a little faster with your crossover study, and you can do that. You can do multiple points a day. There are also some other protocols like EP5 where you can, I think it's 5 days with multiple measurements. So unfortunately, if things like that happen, it is statistics, it is numbers, so you could run 10, maybe 15, a bit more in one day. But remember, we all know the difference when you're running a within run mean or a between day mean. Things like that are always a little bit different. But for your mean, it is more acceptable and easier than to do it for your standard deviation. So our new crossover procedure is now, well, we have our current lot going on. Now we can limit our crossover to 10 days. So 10 days, 1 point a day, we establish a new mean. And what you see is that with that new mean, we're actually going to take our old CV and then calculate our new standard deviation for our new lot. And now we can move forward with our new lot. So it is shortened to 10 points. Another important thing, Dr. Parvin talked about multiple instruments. Well, if you do a crossover study and you have 5 instruments, you need to establish a target. Where does your target come from? Are you going to take one instrument and establish it on the one? Or are you going to use multiple? Well, if you use multiple instruments, your 10 points is still the same thing. Statistically, it's the same power to just measure 10 points. But it is better to measure it across all the instruments, because you'll get more variation and there's different calibrations and everything on those instruments. So for example, I put in here, if you have 4 instruments, then go for 3 days, you get 12 points. So it's never wrong to do a little more. You It's all statistics. The more data we have, the better our estimate is. So you can run a little more. I put a little note in the bottom. Make sure you do at least 2 QCs per instrument. If you have 10 instruments, you could say, oh, I can do it in one day. I run 1 QC on each one of them, and there I go. Be careful if it's just one result, because if that is just a little bit of a difference for that day, measure at least 2, or just 2 or 3 points for each instrument. But that is actually giving you also quite a lot of power, and it's actually probably better to do it across a couple of instruments for your selection of your target than just to do it on one instrument. So as a last part, I just wanted to show you quickly how you could use a data management software for this. And this is a screenshot of Unity Real-Time. And this screen is the duplicate lot screen. So if you have a lot that exists, you would just say to your software, I'm going to make a new lot. You pick the lot number you want to use. You pick the labs or instruments that you want to copy all these lot numbers to. And then see in the bottom that there's a little checkbox where you can say, copy over my fixed SD. So like we said, we can use the old standard deviation. Well, the software is automatically going to copy that over and make that available in your new lot. So when you duplicate your lots, you'll see that in our navigation, we actually now have the 2 lots next to each other. And that is nice because on some instruments, you can run your lot already as a new lot number, and they can both be automatically transmitted to your software, and the software can capture the QC and calculate everything for you. I know not all systems can do that, and sometimes your middleware or your LIS might not be able to handle 2 lots at the same time. So then I know some labs just run it as a patient, their new lot, and then would have to write down or manually go enter those results into the software. So that can work too. But some instruments already have the power of exporting both lots at the same time, and you just capture both. So when you're copying over that standard deviation, in Unity Real-Time, you have both options available. So you could copy your standard deviation, or you could copy the CV. Remember, if your target is very close, you could copy your SD. If your target, your mean is a little different, it's better to copy your CV over to your new lot. So these values would be available already as fixed values in your software. And then you would establish, or you would run your 10 data points. And when your 10 data points are ready, you just go into the software and you say to the software, well, take my cumulative or my 10 days that I have and fix this now as my new mean. What is also important, and I went over it a bit quickly in my overview slide, is even when you have established a mean and you copied over that standard deviation, is that throughout the next months, it's good during your QC revisions or your QC reviews to go and evaluate those targets. Because everything we do with 10 points is an estimation. So it's always better, the more data we get, to go and review if we don't need to tweak that a little bit. Don't just randomly go chase it and change it every month. Make sure you see if there's something going on, yes or no. You can use, again, peer groups as a comparison, or you can evaluate if you have multiple instruments. Is it just one that is moving up, or are all of them moving up? What's going on? But it is important to evaluate that, because it is possible that with some changes or some reagent lots or things like that, that sometimes we might need to adjust that target a little bit. So remember that. And then here, it's also nice to use a visual representation, so Levi-Jennings, like I talked about. So here you would see in Unity Real-Time, you have a multi-Levi-Jennings option. So on the top, you would see our current lot, and then on the bottom, you see our 10 days that we're running our crossover. At the time that we're done, we can just hide and disable the old lot, and then we just continue with the new lot. You can do this nicely next to each other with 2 Levi-Jennings, or you can even put them in the same chart, and now your crossover study is here at the end, and you can see that, like in this example, everything looks okay, and you're ready to go with your new lot. And I think we are ready for questions.